This is the lesson video for lesson 1.5. We're on page 24 in the student journal. So this section is all about solving what are called literal equations, and we are just solving equations that have more than one variable for one of those specific variables. So when you see this language, solve for y, that basically just means to use inverse operations to get y by itself or isolated on one side of the equation. So we do this in the same way that we solve equations when there's only one variable involved. We're still just going to use inverse operations to move everything besides y from the left side here over to the right side. So just like solving an equation, I want to look at what do I have with y on the left side. So I see it's being multiplied by 3 and it has another term added to it. So we want to first take care of or eliminate this adding of 4x from the left side. So to do that, I want to add to 0, so I need to subtract 4x on the left side here to make those add to 0 so that we can cancel them. If I do it on the left, we're also going to do that on the right side. And then the only term remaining on the left side is 3y. And on the right side, we have a 9 and a negative 4x. Now we can't put those together. We can't combine those because they're not like terms. This 9 doesn't have an x too. So this would just be 9 minus 4x. Or you could have written negative 4x plus 9. It really doesn't matter too much either way at this point. So from here, all we need to do now is use an inverse operation to eliminate this multiplying by 3 from y. So the inverse of multiplying by 3 is divide by 3. And if we divide on the left side, we have to divide the whole right side by 3. Now, I'd rather write that out as two separate divisions, but you don't have to write it like that. You could have just done one big fraction bar with a 3 underneath, but this helps me remember that I'm dividing everything by 3. So 3 divided by 3 divides to 1. So now all we have on the left side is 1y. And on the right side here, 9 divided by 3, that is 3. And minus looks like 4 divided by 3x. So that doesn't divide evenly, so I will just leave that as a fraction for now. We don't need to worry about dividing to a decimal. So then this equation now is solved for y. Y is by itself on the left side. And all I did was use inverse operations to move the 4x term to the right and to divide out that multiplying by 3. We will come back to example 2 here in just a minute, but I have a couple more just like that for you to try on the next page. So try 1 and 2, and then pause the video and try those two, and then I'll go through them as well. When I look at number 1, again, I'm solving these for y. I could just as well ask you to solve for x. But solving for y, I want to first move any other terms. So to get rid of negative 2x, I would need to add 2x to both sides. That adds to 0 here, and those can be canceled. Y comes down. And then again, I can't put those two together. So this time I'm going to write it with the x term first, 2x plus 15. We cannot combine those two because they're not like terms. So here, I just have one y. I don't have any numbers in front. So there's no divide step that I need to do. That is now solved for y. When you look at number 2, it's the same idea. I would subtract the 4x from both sides. so that I can add to 0 and cancel 4x's. Y is the only thing remaining, and then I've got negative 4x plus 2 left on the right side. So now that's solved for y. When you look at one like number 5 or 6, notice that the y is negative. So after we move the x term in number 5, again, it's positive, so I would subtract 3x from both sides. That adds to 0, so it's canceled. We have to make sure that we bring that negative down with y for our next line. And here, I can't put those together. Negative 3x minus 4. So really, what are we dealing with here? This is negative 1 times y. So to be solved for y, it needs to be positive y equals. So how do we get rid of that negative? We're going to divide by a negative 1 through our equation, because negative 1 divided by negative 1 makes positive 1, so we just have 1y. Negative 3 divided by negative 1 is positive 3x, and negative 4 divided by negative 1 is positive 4. So even though in that last step we did have y by itself, to be solved for y, it needs to say just y, not negative y. So if you have that situation, you need to divide or multiply the whole equation by negative 1 to make y into a positive variable, which then you can see that changes the signs on every term on the other side. Okay, flip back to page 24. I have one more example for you to write down in the notes section. Example 2 here is a little different in that there are no pluses and minuses like there were in the other ones. So I'm solving for h, so I want to get h by itself. So the end goal, just like here we wanted to end with y equals, here we want to end up with h equals. Since there's no pluses or minuses, what that tells me is that really this is multiplying between every part of that term. So to isolate h and get it by itself, we're going to need to use inverses of multiplying and dividing. There's no pluses or minuses happening here, so we don't have to worry about that. When I look at this, the first thing I want to get rid of is that 1/3. So this is really dividing by 3, so that means I can multiply by 3 on both sides. Dividing by 3 and multiplying by 3 cancels because those multiply to 1. So on the left side we have 3v, and on the right side we have pi r squared h. So again, it still is just multiplying stuff times h. So to the inverse of multiplying these things by h to move them to the other side would be dividing them by h. I need to divide by pi to cancel that out, and I need to divide by this r to the second power. So those cancel. Something divided by itself is 1, and those cancel. Now I have only h left, or remaining on the right side, but I also have to do that on the left side. So now I have 3v over pi times r squared. So am I done? Is h by itself? Sure is. So now, there we go. We've got this second example equation solved for h. Some other examples are 13 and 14 and 15 and 17 on the next 2 pages. So pause the video and try those. Okay, in 13 we're solving for b. So I need to get rid of this 1 divided by 2 and h. So to inverse of dividing by 2 is I would multiply both sides by 2. So that gives me 2a on the left. The divided by 2 and multiplying by 2 on the right multiplies to 1 and cancels out. So we just have b times h. To move, or to undo this multiplying by h, we need to divide both sides by h. So I would end up with b equals 2a over h. b is alone by itself, so we are now solved for b. We did 14 as example 2, so then I'll move to the other two examples on the next page. So number 15 says solve for r. So we want this number by itself. We are trying to end up with r equals all alone on one side of the equal sign. So first we need to think about how do we get r out from under the divide sign. So this is divided by r. I'll write that over here. I equals v divided by r. So if I want to get r out from the denominator, if it's dividing by r, I would need to multiply by r. So r's cancel on the right. Now I have r times I equals v. I want to end up with r equals, that's the goal, so I need to move this I to the other side. So to the inverse of multiplying by I is dividing by I to cancel them out on the right side. I also have to do it on the left side, excuse me, and I also have to do it on the right side. So that means that r equals v divided by I. So again, all we're doing is using the same operations and steps that we used to solve when we just have one variable. The only difference is our end result or our solved equation still has variables in it. One more for you is number 17. We have the equation A equals P plus P times R times T. And it asks us to solve for R. So the first thing I want to do is move any additional terms. So I need to subtract P on both sides to cancel that P out. So on the left we have A minus P, and on the right we still have P times R times T. If we want R by itself, it's being multiplied with P and T, so I need to divide by P and T so that those can divide to 1 and cancel on the right side. If I divide on the right, I also need to divide on the left. So I end up here with A minus P over P times T. Now that is solved for R.